Hey everybody, welcome to the Chapter 7 or the Unit 5 review. This review will cover problems from 7.1 through 7.5. 7.6 and 7.7 will not be on the test. So with that out of the way, let's get started. Number 1A, in the figure below, BC is parallel to DE. Which of the following corresponding proportions is true? Mark all that applies. So you can see here I got two answers, yes, and two answers that are no. So let's look at the first two, shall we? Here it says AD over AB equals AE over AC. So AD is the little leg of the triangle, and AB is the leg of the big triangle, and AE is the little leg of the little triangle, and AC is the leg of the big triangle. So that's why those make sense to me, because it's the same pattern. The one next to it says DE over BC, so the bottom over this bottom equals AE over EC, AE over EC. The reason why this one doesn't work is it should say AD over DB, because that's the only proportion that would work when you're using DE and BC. AE and EC. DE and BC are like, this is the bottom of the little triangle and the bottom of the big triangle, so it's like the total side, whereas EC is like an incomplete side. So AE over EC, the only other proportion that would make sense would be to do AD over DB, because then you're using the little side over the incomplete longer side of the longer triangle. I hope that makes sense. So on C, it says AE over AC, AE over AC equals DE over BC. So that makes sense because you're doing the side leg of the small triangle over the side leg of the big triangle, and then you're doing the bottom leg or the base of the little triangle over the base of the big triangle. So you're still doing a complete side of the small triangle over the corresponding complete side of the big triangle on both fractions. So that's why that one works. And then on D, it says AC over AB equals AD over AE. So AC over AB would look like this long side over this long side. So the right long side over the left long side. And then it says equals AD, the left short side over the right short side. So it would work if you flipped those, if it said AE, the right short side over the left short side of AD, because the other fraction goes right over left, then the other one that it equals needs to go right over left. It can't go right over left equals left over right. So 2A says a cat is stuck in a tree and firefighters try to rescue it. Based on the figure, if a firefighter climbs up the ladder, how far away is the cat? So if you have pieces of the sides of the triangle, you can actually make a proportion with those pieces. So I did 30 over 40 equals x over 46, and then you just have to cross multiply and divide. What's 30 times 46, and then divide that by 40. So 30 times 46 is 1,380, divided by 40 gives you 34.5 for your final answer. Correction, 34.5 feet for your final answer. Got to have that unit there, right? On 3A, it says if triangle ABC is similar to triangle DEF, find the area of ABC if the area of DEF is 60 square feet. So we know that this area is 60 square feet, and we only know one side of each triangle. Because ordinarily, you would just do area equals 1/2 base times height, and all we know is that one leg of the triangle is 12 on the bigger one, and on the smaller one, it's 8. So what you want to do is you want to make a scale factor of your sides, and then you'll want to square that scale factor of your sides to get your scale factor of your areas. The reason why you do that is because area units, in short, area units are in square feet, whereas side lengths are just in like feet. So if your unit is squared, then you want to square your scale factor. If your unit was cubed, you'd want to cube your scale factor of your sides. All right? So I did the left numbers over the right numbers. So the scale factor of my sides is 12 over 8. That fraction is going to simplify to 3 over 2. And then, so squaring 3 over 2 gets me 3 squared is 9, 2 squared is 4. So this is the scale factor of my areas, 9 over 4. So I said 9 over 4 equals x over 60. The reason why it's x over 60 is because you do not know this area, but you do know this area is 60. And so then you just cross multiply 9 times 60, divide that by 4, and you're going to get an area of 135 square feet. So in number 4, it says if ABCD is similar to PQRS, find the scale factor of ABCD to PQRS and the perimeter of each polygon. So what I did was I made a note that the scale factor of your sides is equal to the scale factor of your perimeters, because perimeter is just the singular unit, meaning if your scale factor is, or if your sides say like 8 centimeters and then your perimeter ends up being like 90 centimeters, it's not 90 centimeters squared, so you don't have to square your scale factors. So the scale should be the same for your perimeters. So anyway, let's keep that in mind and see what we got. So what I'm given is 20 and 14, and then I'm given a 25 down here, and that's it. So I put an X on the sides. So these sides are marked, it looks like we have 2 rectangles because these sides are marked as congruent, these are marked as congruent, these are marked as congruent, these are marked as congruent. So this perimeter is quite simple. You can just do that right away without having to do anything with the other rectangle. So I did 2 times 20 and plus 2 times 14, and that's 68. Now, how did I find X? I just made a fraction. I did 20 over 14 equals 25 over X. I did the same corresponding sides over one another. Next, you just have to cross multiply and divide. 25 times 14 is 350 equals 20x, so you got to divide that by 20, and you get an answer of 17.5. So to find the other perimeter, it's just plug in 17.5 here and here. So 2 times 25 plus 2 times 17.5 gives you a perimeter of 85. And then the question did ask you to find the scale factor of ABCD to PQRS. So if I'm going to find the scale factor from this rectangle to this rectangle, I'll take like the corresponding sides and divide them. So I won't do 20 over 14 because that's on the same rectangle. So I'll do 20 over 25. And that's going to equal 14 over, now this is 17.5, and it should equal the same thing as 68 over 85, and they all equal the same thing. If you type them into your calculator, you'll get 1.25, or you'll get a fraction of 5 over 4. So yeah, that would be the scale factor from ABCD to PQRS, just 5 over 4. So question 5 says find the value of x, and we have this triangle here. So the easy way of doing this is just to go 20 over x equals 18 over 9. And you might even be able to do that one in your head because 18 is twice as big as 9. So 20's got to be twice as big as x, making x 10. But yeah, if that doesn't come to you, just make the proportion. 20 over x equals 18 over 9. Cross multiply 20 times 9, that's 180. Divide that by 18, and you'll get x equal to 10. So that's the short and easy way of doing it. The alternative way of doing it looks like this. So you could have chosen to set it up by doing the length of the small leg over the length of the large leg. So that means you would have to add together 20 and x. You don't know what 20 and x is, so you just say 20 plus x for that side. And then you set that equal to like 18 over the length of this leg, which would be 18 plus 9, that's 27. And then when you cross multiply, 20 times 27 is 540, and then 18 times 20 plus x means you have to distribute the 18 to the 20 and the 18 to the x. So 18 times 20 is 360, 18 times x is just 18x, minus the 360 to the other side, you get 180 equal to 18x, divide both sides by 18, and you get x equals to 10. So that's the long way of doing it. I just thought I'd point that out, that you could do it that way too, but the quicker way is to just set it up like this, and I have to imagine most people will prefer setting it up that way too. So number 6 says 2 similar rectangles have a scale factor of 5 to 6. The perimeter of the larger rectangle is 120 meters. It said square meters, but that's not right, so I cross it out. What is the perimeter of the smaller rectangle measured in meters? So like the one, like number 4 was it? I did the scale factor of sides equals scale factor of perimeters. I just wrote that down. So really you just need to do 5 over 6 equals, so 5 is smaller than 6, right? and it said the perimeter of the larger rectangle. So since 6 is bigger than 5, then I gotta have my larger number, my big number on the bottom, and the smaller number on top. So that's why I set it equal to x over 120, because 120 belonged to the larger rectangle. So let's just cross multiply and divide. What's 5 times 20 divided by 6? You get 100. Number 7 says determine which of the following pairs of triangles are similar. I wrote they both are. Here's why. So we have 18 and 24, and in between them is wedged a 42-degree angle. So this triangle looks like it's upside down, but you have 12 and 16 if you were to flip it, 12 over 16 like I did 18 over 24. And they also have the same angle. So it looks like they're going to have side angle side similarity, but you need to test the sides to make sure they have the same, scale factor or proportion, whatever. So I did 18 over 24. That fraction is going to simplify to 3 over 4. And then 12 over 16, that fraction is also going to simplify down to 3 over 4. So it checks out. This triangle here, the LMN that's inside of LPQ, what I did was I did the 12 over 8, and that simplifies to 3 over 2. And so I wanted to know the whole side of this, so I just put the 10 and the 5 together because I'm using the sides of LPQ. So I have 15 over the smaller triangle, we would use the 10, and that also simplifies to get 3 over 2. So these proportions were the same, so I can conclude that both these triangles are similar. Number 8 says which polygon is or are similar to ABCD. So really you just need to create a proportion. What I did was I did the short side over the long side. So 4 over 12, that fraction is going to reduce to 1 over 3. So I'm going to go to my options here, and 6 over 18 simplifies to get 1 over 3. The second one, I did 2 over 3 divided by 2. So it's kind of weird because it's a fraction. So when you're typing it into your calculator, you'll want to put this 2 over 3 in parentheses, and then you'll want to put the divide 2 on the outside of the parentheses, and it'll tell you it's 0.3 forever or 1/3 depending on the calculator you're using. But yeah, so it's also the same ratio. And so 2 over 6, that simplifies to get 1 over 3. And then this one says 8 over 8, that simplifies to get 1. So that one is not similar to this one right here. Number 9 says find the value of x. The picture's a little tricky because they give you two sides here, so you got to use your judgment. What side should I use? Because I can easily do 16 over 10, but what am I going to set it equal to? 9 over x or 12 over x? So look at the angle that 16 is touching or adjacent to. So 16 is adjacent to this angle here, which has the 1 mark. And so the 9 is adjacent to the angle with the 2 mark, so I wouldn't use the 9, I'd use the 12. It's also adjacent to the 1 mark. So here I have it set up, 16 over 10 equals 12 over x. Cross multiply and divide. What's 10 times 12 divided by 16? You'll get 15 over 2 or 7.5 for your final answer. So with that being said, that's going to wrap up the review. Thank you for watching. Good luck on your test, and goodbye.